Hi, hello, namaste. I am Ramchandra Bhatt, working as a science teacher at Government High School, Batrayanpura. Welcome to the revision classes. You are eagerly waiting for this. In this session, you are going to learn about first chapter in the science, that is chemical reactions and equations. In this session, you are going to learn about writing and balancing the chemical equation, types of chemical reactions, that is combination, decomposition, displacement, double displacement, oxidation and reduction reactions, endothermic and exothermic reactions, effects of oxidation and reduction reaction in our daily life like corrosion and rancidity. Now, let us understand these concepts one by one. Let us move on to next slide, that is the first one is changes takes place during the chemical reaction. It is very simple mnemonics for you, that is GST on PC. What is this? While purchasing anything, you have to pay GST that you studied in social science. I purchased a personal computer PC and I paid GST. I used this one for remembering the changes during the chemical reaction. Each capital letter stands for each change. Observe this one, that is G stands for evolution of gas during the reaction. The next one is state, that S stands for state, change in the state. Similarly, the next one is change in the temperature. Next one is formation of precipitate and change in the color. These are the 5 important observations can be done during the chemical reaction. Now, let us move on to next slide, that is chemical equation. Symbolic representation of a chemical change is termed as chemical equation. So, here we are using suitable symbols and formulae to represent this one. The simplest way to represent a chemical change is to write it in the form of a word equation. Let us have an example for this one, that is for burning of magnesium ribbon, that can be written like this: magnesium plus oxygen, arrow mark, that is gives rise to magnesium oxide. Left hand side we are writing reactants and right side the products. Remember children, these terms are also very important. Now, let us move on to the next slide, that is method of balancing the equation. First, you have to write skeletal equation. It represents what are the reactants and products are there. First, you have to tabulate each one like this. So, the element first you have to write magnesium, then oxygen. Number of atoms present in the reactant left hand side, that is I listed 1 magnesium, oxygen 2. Number of atoms in the product side, both are 1 1 each. Now, let us try to balance it. Oxygen is left side 2, right side 1. So, I will write 2 before MgO, then magnesium becomes 2. So, left hand side I have to write 2, then your balanced equation is ready. This is 2 Mg plus O2 gives rise to 2 MgO. You can enjoy this activity through a game, that is FET simulations are available in the online. So, you will learn and enjoy the balancing action. So, learn and enjoy. Let us move on to the next one, symbols used in the chemical equation. Sometimes we are not representing, sometimes we are representing. Usually physical states are not included in a chemical equation unless it is necessary to specify them. But many times we are using the reaction conditions such as temperature, pressure, catalyst, they are indicated above or below the arrow in the equation. Here is an example, that is carbon monoxide, which occur in gaseous state, G representing. 2H2 gaseous gives rise to, on the arrow mark you are seeing 340 atm indicating atmosphere, that is the pressure. For the reaction you have to apply 340 atmospheric pressure, then you are getting methanol which is in liquid form. One more example is very important, already you learned this equation, that is the photosynthesis. What are the conditions are given here? Carbon dioxide is in aqueous form, water liquid form, on the arrow you are seeing sunlight. That means sunlight is very essential for the reaction. Then it takes place in the chlorophyll, that is the green pigment you studied in life processes. What is the product produced? Obviously, that is the carbohydrate glucose. In addition to this one, we have very important respiratory oxygen, respiratory gas oxygen and water. Now, let us move on to different types of chemical reaction. The first one is combination. What do you mean by combination? When two different things, here you are having two reactants, they combine to form a single product, then you call this one as combination. Very simple. Similarly, we have such many reactions listed in the textbook. You can learn and understand what is that. One more example is combination of calcium oxide and water to form calcium hydroxide, which is commonly known as slaked lime. In addition to this one, heat is released, hence it is exothermic. So, it is one of the type of chemical reaction. Dear students, let us enjoy the activity of combination through practicals. Here is the magnesium ribbon. I prepare the magnesium ribbon by rubbing against sandpaper, because it reacts with the oxygen and produce magnesium oxide. You have to remove the surface of magnesium oxide layer. Now, let us heat. Observe carefully. This is the oxidation reaction. You should not perform the activity without spectacles. Use the spectacles and perform the activity, because the bright light produced during the reaction may harm your eyes. The next one is exothermic reaction, just now I told. The respiration is an example for this one. We get energy by combusting glucose during the respiration. So, glucose plus oxygen gives rise to carbon dioxide and water plus energy. This equation also studied in the life process chapter. The reactions may be endothermic. Example for that one is photosynthesis, which is opposite of respiration. Here carbon dioxide and water is absorbed by the green plants, and they also absorb sunlight. Energy is taken in, so endo. So, this is endothermic reaction. Now, let us move on to next one is decomposition reaction. Very simple analogy I can give, that is same thing. I have one reactant, I will break the bond and I will get two products. Very simple, you are seeing the animation also. AB compound decomposes by the application of energy and produces A and B two products. Thus, decomposition reaction where one reactant breaks up into two or more products. Such reactions are termed as decomposition. Decomposition reactions further classified into three based on how they are decomposed, maybe by the heat, maybe by the light, maybe by the electricity. Here is an example: thermal decomposition. 2FeSO4 solid decomposes on heating to produce ferric oxide, a brown colored compound. Earlier it was greenish compound, salt. SO2 plus SO3, two gases are produced during the process. Now, one more example for thermal decomposition is calcium carbonate decomposes to produce calcium oxide plus carbon dioxide. The reaction in which heat is used, then you call that one as thermal decomposition. Now, let us move on to next very important, that is electrolytic decomposition of water. Here water is broken down into constituent elements. Such reaction done by using electric current is said to be electrolysis or electrolytic decomposition. You are here watching very important diagram. Observe the diagram carefully. Observe the volume of hydrogen and oxygen, that is in the ratio of 2:1 compared to hydrogen 2 volume, oxygen 1 volume, indicating they are in the same ratio 2:1. Dear students, let us understand electrolysis through simple activity. You need a waste plastic cup, and also observe here 2 drawing pins are pricked, they act as electrodes. So, here you are reusing and reducing the waste, recycling it, repurposing it. So, you can remember this one for your biology chapter also. Now, I need a battery, test tube, salt and water. Let me pour some water into this cup. Let me add some amount of salt. Let us dissolve salt. Salt acts as an electrolyte. Let me dissolve the salt and now observe what happens carefully. Are we observing any change? You are observing beautifully the gas is evolving at cathode. That is the hydrogen gas. Is it possible to collect this gas? Yes, you can easily collect with the help of a test tube. Fill the test tube with the water. So, now I am inverting over the terminal where the hydrogen gas is collected. Now, observe, once again I am connecting to the battery, observe the change. So, here you are observing the evolution of gas at cathode. This is the hydrogen gas. You can collect and you can perform simple activity to test it. It burns with a pop sound. This is the electrolysis of water. Now, let us move on to next one, that is photolysis. Photo, light, lysis, breaking down. During the chemical reaction, light is used to break down the compound, then you call that type of reaction as photolysis or decomposition by the light. Example are here. 2AgBr when exposed to sunlight breaks up into constituent elements silver and bromine. Bromine is reddish brown colored vapors. After the decomposition, silvery white element, in addition to that one we have reddish brown vapors. The next one is 2AgCl. On exposure to sunlight, Ag plus Cl2, Cl2 is greenish gas, silver already you know that one. This is called as photolysis. This is very important reaction used in black and white photography. Now, this also called as endothermic because energy is taken in, then reaction takes place. To break the bond between silver and chloride, silver and bromide ion, we are using sunlight. Hence, it is photolysis. Here is the diagram to represent this reaction. What are you observing? Yes, this is displacement reaction. You are right. When Fe reacts with CuSO4, you are seeing the displacement reaction. Gradually color change takes place after half an hour or so, like that. Let us represent the reaction through equation, that is Fe plus CuSO4 gives rise to FeSO4 plus Cu. Let us take one more example for this one, that is with the help of activity series. What is the importance of activity series here? How to understand whether the displacement takes place or not? If you know the reactivity series, you will easily write the answer for these type of questions, because you have to think which is reactive, which is less reactive. More reactive element displaces the lesser one from its salt solution. That type of reaction is said to be displacement reaction. This is the reactivity series. See here, potassium is most reactive and platinum is the least one. Where is our Fe? That is more reactive, upper in the order, and Cu is lower in the order. Obviously, Fe displaces the Cu, not vice versa. Now, one more example here, that is zinc reacts with copper sulphate. Then zinc sulphate plus copper is formed. Gradually, the blue color of copper sulphate disappears and turns into white. This is the important observation during the reaction. Then one more reaction, that is the reaction of lead with copper chloride, that forms lead chloride plus copper. Let us compare Fe, Zn, Pb and Cu, which is more reactive. So, obviously you will tell zinc is up, then comes Fe, then comes Pb, then comes Cu. This is the arrangement of these elements according to their reactivity. These type of questions are possible in the examination. So, carefully observe and use reactivity series in the first chapter itself. Dear students, now let us understand displacement reaction through an activity. So, here is copper sulphate, the blue colored solution, and two iron nails are kept, for one is for comparison, one for reaction, and magnesium strip also there. Let me pour copper sulphate solution into this petri dish. Now, let me immerse an iron nail into the solution. Now, let me add magnesium ribbon into the solution. Observe the change. What happens? You are observing the change in the color of the solution also and nail also. Let me show. Reddish deposition is observed over iron nail, that is nothing but copper. See, copper is displaced by iron. Similarly, magnesium ribbon also changed its color, indicating displacement reaction. Mg plus CuSO4 gives rise to MgSO4 plus Cu. Here more reactive element is displacing lesser one. Now, let us move on to next one, that is double displacement reaction. What are you observing? The two test tube contains two crystal clear white watery solutions, but when you mix them you are getting a magic. So, that is the double displacement. When Na2SO4 combines with the BaCl2, both are aqueous watery crystal clear solutions. When you mix them together, BaSO4 plus NaCl is formed. Here BaSO4 is solid, it is called as precipitate. Any chemical reaction during which a precipitate is formed is termed as precipitation reaction. A double displacement reaction can be a precipitation reaction also. Here it is an example for precipitation. Now, let us see one more example for this one. So, that is reaction of potassium iodide and lead nitrate. When they combine with each other, they mutually exchange their radicals and form a new compound. Old bonds are broken and new bonds are established to form a new substance, which is having a different set of chemical properties. Hence, it is a chemical change. Let us perform very simple activity to understand this magical moment. You will enjoy the color change. Dear students, now let us understand double displacement through very funful activity. Here is potassium iodide and lead nitrate. Already I prepared the solutions of these two. Both are crystal clear watery liquids, that is aqueous solution of lead nitrate and potassium iodide is ready. Observe what happens when these are mixed. Let me mix them together. Carefully observe. You will observe a magic color change. So, precipitate of lead iodide is formed in this solution. If you keep this one for some time, the precipitate settles, and already I prepared the solution. You will observe here the precipitation formation. If you keep this on for half an hour, you will observe deposition of solid precipitate at the bottom. Now, redox reactions, where reduction and oxidation takes place simultaneously. Such reactions are termed as redox reactions. How to distinguish, how to identify? I have a chart for you, that is oxidation and reduction. Oxidation, addition of oxygen or removal of hydrogen. Based on that you can tell whether this is oxidation or not. Addition of oxygen is termed as oxidation, removal of oxygen is termed as reduction. Now, in terms of hydrogen, removal of hydrogen is termed as oxidation and addition of hydrogen is termed as reduction. Third type is in terms of electron. Removal of electron is termed as oxidation and addition of electron is termed as reduction. Let us understand with an example. Sodium ion Na plus takes one electron and becomes Na. Here we say Na plus is reduced to Na. Metals are reduced at cathode during the electrolysis process. So, we are explaining this reaction in terms of electron. The next one is 2 Mg plus O2 gives rise to 2 MgO. This is an example for oxidation because addition of oxygen you are seeing here. Now, let us see one more reaction, that is MnO2 reacts with HCl to produce MnCl2 plus water plus chlorine. Here MnO2 loses oxygen. So, loss of oxygen is what? Yes, reduction. So, reduced product is MnCl2. HCl loses its hydrogen, loss of hydrogen is oxidation. So, HCl is converted into Cl2. Thus, you can easily identify what is oxidation, what is reduction with the help of 3 criteria. Remember this one? Higher order thinking questions are possible here. Now, let us move on to next one. Think. You have to think and you have to analyze the situation, then you have to write the answer. When a reddish metal X is heated in air, it forms a black compound Y. Probably you observed this one at home. Electrical appliances due to short circuit becomes black. The copper coil inside that becomes black. Y reacts with a gas Z, which is a product of electrolysis of water. During the electrolysis, possibilities hydrogen and oxygen. Already we heated in presence of oxygen. Now, only left out option is hydrogen. So, hydrogen is used here. When hydrogen reacts with this compound, you are getting back the element. You have to identify X, Y, Z. Probably you got the idea and you have got it and you got the answer also. Let us see the answer. X is copper, reddish metal, only metal given in the textbook is copper, so that is copper. Why is copper oxide? When copper coil is combusted in presence of oxygen, black compound, copper oxide is formed. Now, Z, that is the product of electrolysis, hydrogen. Now, let us write equation. Cu plus O2 gives rise to 2CuO. Here addition of oxygen, one more type of reaction, that is oxidation. Now, copper oxide converted back to copper by adding hydrogen, that is reduction. Thus, you will easily identify the reaction X, Y, Z, etc. So, these type of questions are very, very important in the examination perspective. Now, let us move on to next one, that is redox reaction. The previously I wrote the equation, now you are seeing what is oxidized and what is reduced product. copper oxide is converted into copper. What happened here? Lost oxygen, right? So, loss of oxygen is called as reduction. Similarly, you are adding oxygen to hydrogen to form water. So, hydrogen is oxidized to water. Here is copper oxide is oxidizing agent. Remember children, oxidizing agent reduces itself. See here, copper oxide loses oxygen and becomes copper. So, it reduced, but it is oxidizing agent. Remember this one. Do not get confused here. Next one is hydrogen, reducing agent, but oxidizes itself here to water. Next one is copper is reduced. So, that is the reduced product. Similarly, water is oxidized product. Thus, you can easily identify what are various terms related to a reaction. Now, one more thinking, you have to think and answer to this question. When water is added to a white solid X, a hissing sound is produced and a lot of heat is released and Y is formed. That is the product. A suspension of Y in water, which is used for whitewashing, and a clear solution of Y is used for testing the carbon dioxide. So many data are given, then you have to analyze, then you have to answer. Very simple trick you can play here is water added to white solid may be calcium oxide or something else. Let us guess. Suspension of Y in water is used for whitewashing, quickly gives the hint, that is slaked lime, calcium hydroxide. Calcium hydroxide is used for whitewashing, and calcium hydroxide, it is lime water, through which if you pass carbon dioxide, it turns milky. That is the test for carbon dioxide. Now, you got many hints. Now, what are the X, Y? Write the equation for this one. Let us analyze. Here X is calcium oxide. When calcium oxide is added to water, hissing sound is observed, large amount of heat is generated. It produces calcium hydroxide, hence Y is CaOH twice calcium hydroxide or slaked lime. Then the reaction is calcium oxide CaO plus water H2O, arrow mark gives rise to calcium hydroxide with the liberation of heat. So, it is an example for exothermic also. Now, one more reaction, calcium hydroxide lime water through which carbon dioxide is passed produces insoluble precipitate, that is milky white precipitate of calcium carbonate. Now, one more thinking question, that is a white solid X on heating produces yellow solid L. Reddish brown gas Y and a colorless gas Z is produced during the process. Z is used for roasting. This is one more hint. Y is an acidic gas. Identify X, Y, Z and L with the suitable reason, and also you have to write type of reaction with equations. Many hints are given here. Reddish brown gas is nitrogen dioxide, which is acidic in nature. Roasting, we are using oxygen. Thus, the hints are helping you to understand this reaction. This is the decomposition of lead nitrate. X is nothing but lead nitrate. Nitrogen gas released means it should be a nitrate salt. Nitrate, lead nitrate, that is the X. Now, Y is nitrogen dioxide, a brownish gas. Then Z is oxygen. Thus, you are getting many things very easily. The L is nothing but yellowish compound lead oxide. Now, the reaction is PbNO3 whole twice on heating decomposition, thermal decomposition produces yellow color lead oxide, nitrogen dioxide and oxygen. So, thus you can analyze and answer to these type of questions. These are called as higher order thinking questions. Some data are given, based on that you have to analyze and come to a conclusion. That is the inference. So, I hope you will understand these things. Thus, many things are easily understood and you can score the marks also. One more thinking question is, when a green iron salt is heated strongly, its color changes to brown and odor of burning sulfur is felt. Name the iron salt. Already you studied this one, so you can easily remember ferrous sulfate, green colored salt. The next one, name the type of reaction that takes place during the heating of iron salt. This is nothing but thermal decomposition. First, loss of water takes place, that is the water of crystallization. After that, it loses water and becomes brownish colored substance on decomposition. Now, the next one is, write the chemical equation for the reaction involved. 2FeSO4 on heating gives rise to Fe2O3 ferric oxide plus sulfur dioxide and sulfur trioxide. This is the reaction you have to write. Now, a student argued burning of magnesium is an example for combination reaction, while another student argued it is an example for oxidation. Who is correct and why? Or any other answer is there? Think. Yes. Now, both students are correct. How they are correct? Let us write the equation first. Mg, 2Mg plus O2 gives rise to 2MgO. Two reactants combine to form a single product. Then a student argued it is an example of combination. This is right. It is combination. Another student argued it is oxidation because addition of oxygen. So, he also correct. One more option. What happens here? During the reaction, large amount of heat as well as light is produced, hence it is exothermic also. Thus, we can analyze the question and come to conclusion. These are little bit thinking, HOT, higher order thinking questions. Now, effects of oxidation and reduction in our daily life. This is very important segments because we are seeing many things in and around us. So, we should aware of these things. Corrosion, very important aspect because of oxidation. What do you mean by corrosion? Corrosion is the process in which eating up of metal surface by the action of air, moisture or a chemical like acids or salts. This process is said to be corrosion. Iron get corroded on exposure to atmospheric oxygen and water and becomes rust, which is called as hydrated ferric oxide. You will learn this in 3rd chapter. Similarly, silver articles on exposure to atmosphere becomes black. Why? This is because atmospheric sulfur combines with the silver and forms silver sulfide, a black colored coating. To remove this one, you have to apply some basic substance, then you can easily remove this one. Toothpaste has such kind of compound, so if you apply a little bit of toothpaste over that, it removes. Similarly, copper vessels on exposure to atmosphere turns greenish because of deposition or formation of greenish compound, that is ferric carbonate, which is basic in nature, CuOH twice dot CuCO3. This is called as basic copper carbonate. To clean this one, we are using acidic substance. So, you will learn that one in next chapter. So, these are the impact of redox reaction in our daily life. Rusting can be prevented by applying oil, paint or alloying or some other methods. Now, let us understand one more impact of this reaction is rancidity. Rancidity is nothing but oxidation of oily food. On exposure to atmosphere, oil, food get oxidized and bad smell is felt. Food becomes stale because of this. Hence, this is a serious problem. Then how to avoid this one? Rancidity can be prevented by keeping the food in airtight containers and also flushed with nitrogen gas, and also keeping in the refrigerator also controls to certain extent. Now, let us move on to the next one. Here are some reference links. You will enjoy some video animations which help you to understand better. So, watch these, understand these, prepare yourself for the examination. I hope you will do wonderful in the examination. All the best. Thank you for watching. Bye bye. Namaste.